Hi, I'm Mr. Eric Tang. The objective of today is to help you to completely understand what ASCII code is. Let's start with the following example. Here we have 5 characters. The first thing you should know is that computers are just machines which can only store and manipulate numbers. Therefore, everything we are referring to must be represented by a number. This process is called encoding. Therefore, if we want to process characters in computer, we must assign a numbers to each character. We call this character encoding. You can see now we represent A to E by 65 to 69. The second thing you should know is that computers must store numbers in binary form. Therefore, the actual storage of these numbers are like this inside computers. Therefore, if you type a letter A on a keyboard, it actually sends a signals of 65 to computer and is stored as 01000001 in computer memory. Now, when you transfer the letter from one computer to another computer, it actually sends this bunch of bits to other computer. Here's another question. How does the other computer know that this bunch of bits represents the English character A? The answer is that we need a common encoding method or standard so that everyone knows that under this standard, we know the number 65 or the bit pattern 01000001 means the character A. In fact, this standard for encoding English characters is called ASCII. It stands for American Standard Code for Information Interchange. ASCII encoding standards defines a code for each uppercase and lowercase English character A to Z, numerical character 0 to 9, commonly used symbol, and some invisible control character, which can be used to control a printer like changing a new line. In total, ASCII standard defines 128 number of characters, symbols, and invisible control characters. This table summarizes all the codes defined in the ASCII standard. In this table, you can see the code for the capital letter A is 65, while the code for the small letter A is 97. Therefore, we say the character set of ASCII contains 128 different characters or symbols. The code range is from 0 to 127. Therefore, 7 bits are enough to represent 0 to 127. As you know, the largest code, 127 in binary, are only 7 ones. However, in the real implementation, we need to use at least 1 byte, that is 8 bits, to store one ASCII code, as byte is the smallest unit of storage for a single memory address. Therefore, that's why we usually say that one English character in computer needs 1 byte of storage. Let's finally see one more example. Suppose we instruct a computer to read text with ASCII encoding from a text file. Since it knows that ASCII encoding stores each character by 1 byte, it will then read out the first byte. Here it is 67. Then it will display the character as C. Then the second byte, it is 65. Then it knows from the ASCII standard that it is A. Then it will display the character A on the screen. The next byte is 84. Then it will display the character T. Okay, thanks for watching. I will talk more about ASCII encoding in the next video. Please give me a like if you find this video useful. Goodbye.